Hey, in this example, what we're going to do is look at net change for something. In other words, what's the total change that happens, even though it moves all around, how far does a particle actually go, or how much area do we actually cover, or questions of that nature. So what we want to do is we're going to take a look at this velocity equation here, t squared equals, or t squared minus 8 over t plus 1 squared. It gives us this graph shape right here. The initial value on this guy is right here at 0. This is when x is 0. And right there when x is 0, if you put a 0 in for all the t's, you're going to have an initial value of 8. All right. So we would say that our initial value for this, if we're going to describe the motion, we'd say our initial value is -8. That should be a -8 down there. Okay, -8. Or what we would say is 8 seconds, 8, yikes. Let's say that this is, let's give our velocity here some legs, like let's call it centimeters per second. So if we're dealing with velocity, so then what we'd say is we're moving 8 centimeters per second to the left. Okay, 8 centimeters per second to the left. Anything down here is going to be to the left, or away. Depends on what you're trying to interpret. This is usually the guy right here that we're going to use to interpret. It's usually going to be to the left. Okay, somewhere right around in here, we come to a stop. All right, and if we did a little looking, if we plugged this into our calculators and checked it out, we would see that when t is about 1.25 seconds, then we would have a velocity of 0 centimeters per second, because now instead of moving to the left, we're stopping and moving to the right, or instead of moving away, we're stopping and moving toward. Okay, so then if we go above the x-axis, this would be to the right or forward. Think of it as forward. Maybe away is a bad way. Maybe if we said like reverse, that's probably a better way to say that. Okay, so to the right or forward, or to the left or reverse. And all this means is the further we are away from the x-axis, the faster we're moving in that direction. Okay, so we start off at -8 centimeters per second to the left. At 1.25 seconds, we now have 0 centimeters as we're changing from left to right. And then we could finish this by saying, when t is greater than 1.25 seconds, we're moving to the right, and our velocity is increasing. Okay, so we move to the right and velocity increases as we go. How do we know? Because the distance from the x-axis increases, and as that distance gets larger, you're moving quicker. Okay, so we move to the left, we stop, we move to the right, and we go fast, fast, fast. So we're slowing down, stopping, moving to the right, and increasing our speed. So that's the original setup for this problem. We've talked about this a little bit before. We're going to talk about it in a lot more detail in the next lesson.